We are the BAC Science Education Consultants, and we are here to ensure that you don't have any reason to pause the process of learning about electrolysis. We are coming with our lesson today about electrolysis of aqueous sodium chloride solution. In the previous lesson, we have studied that there are two types of substances that can conduct electricity. We have one that we call a conductor. We have another one called an electrolyte. The conductor conducts electricity because it contains free and mobile electrons. But an electrolyte conducts electricity because it contains free and mobile ions. And we said those ions cannot be free and mobile unless it is either in solution form or in ionic form. We looked at how molten electrolytes can behave as they conduct electricity. And today we are going to see how we can use aqueous electrolytes to conduct electricity. Remember ionic theory of electrolysis, that any electrolyte contains ions. If an electrolyte contains ions, in this case, our electrolyte is sodium chloride. Our electrolyte is sodium chloride. And it is a solution, so it is aqueous. Which electrolytes, which ions does this electrolyte contain? This is our electrolyte, an indicator that it must be containing ions, and therefore ions present. We have two substances in our electrolyte. One of them is sodium chloride, which in solution ionizes completely because it is a strong electrolyte, and it gives us sodium ions and chloride ions, and both of them are aqueous. We as well have water. Why am I talking about water? Aqueous. Aqua means water, meaning this is a solution that is made using water as an electrolyte. Therefore, we are talking about a solution that contains water. What are the students? Therefore, this water as a weak electrolyte ionizes partially. Remember, we talked about a weak electrolyte and a strong electrolyte. And among the weak electrolytes, we talked about water. But we said water that is pure is too weak to conduct electricity. Why? It does not ionize most of the times. But if it is impure, like in this case, water is impure. Hope you can differentiate between something that is something that is impure and something that is contaminated. When we talk about impure water, it means that water that is containing anything else. But water that is contaminated, it is water that is containing anything that is harmful to any process that it is intending to serve. So, this is going to contain hydrogen ions, which are aqueous, and hydroxide ions. Meaning that our ions, the ions that we have sodium ions, we have chloride ions, we also have hydrogen ions, we also have hydroxide ions. During electrolysis, what happens? During electrolysis, what happens? And we are going to talk about what happens at the anode and maybe what happens at the cathode. At the anode, what will take place? We remember that the anode is positively charged and the cathode is negatively charged, which means that first of all, since anode is positively charged, it is going to attract ions that are negatively charged. Therefore, the chloride ions and hydroxide ions are attracted. And then at the cathode, which is negative, it is going to attract the positively charged ions, and so it will attract sodium ions and it will and the hydrogen ions. They are attracted. Remember, this is when you have put this electrolyte in an electrolytic cell and you have applied electricity onto it. We have not gone into the details of drawing that diagram because you are now experts of drawing such. And when these ions are attracted, then what happens to them? What happens to them? We know that when we are talking about electrochemical series, chlorine is on top of hydroxide. Sodium is on top of hydrogen. And you know from the selective discharge, the factors that affect selective discharge, we said an ion that is lower than the other in the electrochemical series requires less energy for discharge, and therefore it will be chosen for discharge. Meaning that in this case, the hydroxide ions are selected for discharge. And the reason is it is lower. The high OH ions are lower than the chloride ions in the electrochemical series. In the same way, the hydrogen ions here are selected for discharge. Instead of sodium ions. And the same reason applies here. That is because H plus is below Na plus in electrochemical series. Don't forget to know that the ion that is lower in the electrochemical series is basically chosen for discharge because it requires less energy. When hydroxide ions are discharged, discharge, we said it means removing the charge, losing the charge. Discharge, it is the opposite of charge. Meaning, when hydroxide ions get discharged, they will form two molecules of water and oxygen gas. And for an anion to get discharged, it will have to lose electrons. And in balancing, we find that we end up having 4 electrons being lost since we have 4 molecules of hydroxide involved in the reaction, and each one is losing 1 electron. In the same way, when hydrogen ions here get discharged, you will find that since hydrogen ions are positive, they get discharged by gaining electrons to form hydrogen gas. hydrogen gas is H2. In actual sense, one hydrogen atom would have been formed, but whenever an atom of hydrogen gas exists in presence of other atoms, we know what happens. Covalent bonding. It will attract another hydrogen atom. They share electrons to form hydrogen gas, meaning you need 2 ions per hydrogen molecule that is formed, meaning basically you will need to gain 2 electrons for you to form hydrogen gas. This is not all. What is observed? What is observed? What is observed? We shall see that this is colorless, this is colorless, therefore the solution will remain colorless. After all, even sodium chloride is colorless, but what will come out? As the gas is coming out of a liquid or a solution, we shall see bubbles. Bubbles, and since oxygen is colorless, we shall have bubbles of a colorless gas. And here, in the same way, hydrogen is coming out of the electrolyte at the cathode, and it will also have the same observation as bubbles of the colorless gas. Bubbles of the colorless gas. There is something very important that we have to talk about. The factors which affect selective discharge of ions are 3. As we said, one of them is position of the ion in the electrochemical series. The other one is the concentration of the ion in the electrolyte, and the last one is the type of electrode that you use. Meaning, we shall now go back and look at this. Sodium chloride ionizes completely. It ionizes completely, meaning more sodium ions will be formed. This will be many, this will be many. They will be in higher concentration. This is ionizing partially, but you see, even after ionizing partially, the ions which it produces are the ones which are discharged. There is something we have to consider: the concentration. What is the concentration of sodium ions when compared to the concentration of hydrogen ions? What is the concentration of chloride ions in relation to the hydroxide ions? We have to talk about concentration. And we shall see that basically, since sodium chloride is a strong electrolyte, the concentration, this is NB number 1, of Na plus and Cl minus are basically high. Concentrations are higher than the concentrations of hydrogen ions and hydroxide ions. Yet they are the ones that are getting discharged. Remember, we said when an electrolyte is in higher concentration, it is selected for discharge, provided the energy required for its discharge is significantly lower than the concentration of the other ion that is in lower concentration. Meaning that we shall say that at the cathode, there are no chances of discharging sodium ions. There are no chances at all, provided you have used inert electrodes. Provided you have used inert electrodes, there are no chances of producing sodium at the cathode. But At the anode. Maybe before that, we can talk about the reason. Why can that happen at the cathode? The reason, we need this reason. The reason is because discharging sodium ions requires very high energy. It requires very high energy when compared to discharging hydrogen ions. Much as sodium ions are in higher concentration, they will not be discharged due to the high energy required. But at the anode, some chloride ions are discharged. Because discharging chloride ions and discharging hydroxide ions, yes, the difference in energy is there, but it is not as much as the difference between discharging hydrogen ions and sodium ions. And in addition, chloride ions are far in higher concentration than hydroxide ions, like we've said, because sodium chloride ionizes completely and it ends up forming many chloride ions. And therefore, we shall see that this chance increases with increase in concentration. With increase in the concentration of sodium chloride solution. Of course, up to a certain limit. But as you continue increasing concentration of sodium chloride, you are increasing its chances of ionizing, and therefore you increase the chances of having more chloride ions, and in the other way round, you are reducing the amount of hydroxide ions. Because if you have concentrated sodium chloride, it means you have sodium chloride with very little water as the solvent. So the water is little and it is ionizing partially. Sodium chloride is too much and it is ionizing completely. An indicator that you will reach an extent when an extent is reached. An extent is reached when only chloride ions are discharged. When only chloride ions are discharged. We are good to go. And we are here to make sure that you continue receiving such quality work day by day, even in what is called a lockdown. Please continue learning and continue with us. Don't forget to subscribe to our channel, Science Education Consultants. I remain Teacher Ambassador Osbert.